Now, since I is just another number, like all other numbers, I to the 0 power is just equal to 1. This may seem a little bit funny because 1 is a real number, but I think this is more a testament to the fact that I and all other imaginary numbers are in fact numbers. I to the first power is just I squared is I times itself, which means we're multiplying the square root of -1 times the square root of -1. That should just give us -1. Now I cubed is going to be I squared times I. So we have -1 times I, which is -I. Interesting. So we only have 1's and i's, the positive and negative versions over here. Let's see what happens in this column. I to the fourth should be I to the third times I again. That means we're multiplying the square root of -1 by itself and then taking the negative of that number. So this is -1, which is just equal to 1. Oh, that's funny. That's the same as I to the 0. I to the fifth is I to the fourth times I. So 1 times I, which is I again. That's the same as I to the first. And we can see the pattern continues for I to the sixth and I to the seventh. So it seems like when we take powers of I, the numbers that they're equal to alternate in a cyclic way. We go from 1 to I to -1 to -I, back to 1, and so on. I think this pattern is really interesting. And keeping this in mind is going to help us remember the relationship between real numbers and imaginary numbers.